Hello students, in this lesson we will give an introduction to the general concepts of network hardware used in different types of network. You will understand during this lesson about the various network hardware devices with their specifications and applications of basic components. Let us start with an example of sharing the resources.
There may be a computer that doesn't have a DVD drive. In this case, one can place a movie disc on the computer that has the player and then view the movie on a computer that does not have the player. In order to do this, we need to establish a computer network and to develop networking. For this, we need various types of hardware devices and software. Networks have become popular as they are used to share computer resources electronically, such as printers, CD-ROM drives, application programs, and the information the users need to do their work.
Prior to the existence of the network technology, individual computers were isolated from each other and limited in their range of applications. By linking these individual computers, their usefulness and productivity has increased enormously.
The two types of reference models are OSI model and TCP/IP model. Let us talk about the OSI model first. Physical link of all devices are at physical layer of OSI reference model. When we connect a device to a system, it communicates with the other layers. A committee whose basic objective is to standardize the rules of interaction between interconnected systems is known as International Standard Organization, popularly known as ISO, and the OSI reference model has been developed by them. It is a conceptual design plan of how communication should take place. It particularly describes all the processes required for effective communication and breaks these processes into logical grouping called layers. Therefore, this design is known as layered architecture, and OSI is not a physical model. The TCP/IP reference model is the network model used in the present Internet architecture. The major design goals for this model are: it has ability to connect multiple networks together uninterrupted. It has ability for connections to remain linked as long as the source and destination machines are active. This reference model was named on its main protocols, TCP, which stands for Transmission Control Protocol, and IP, that is Internet Protocol.
In computer networking, we need to use various reference models, protocol suites, networking operating system, and networking hardware. Here, we will first define the terms to understand process of developing network, such as hardware, network, network hardware.
Let us talk about the hardware first. All the physical devices, peripherals, and equipment, including the digital circuitry, are called computer hardware. For example, monitor, mouse, keyboard, scanner, printer, modem, etc. Computer hardware is used in all modern-day automobiles, microwave ovens, electrocardiograph machines, compact disc players, and other devices. The hardware of a computer is not changed frequently in contrast with software and data. The present computers are much advanced in terms of processing speed and have an efficient memory structure. The second element is the network. A group of computers connected together is called network. For example, LAN, MAN, and WAN. Each type of network is classified on the basis of coverage area. LAN. A local area network, or LAN, popularly called LAN, is a computer network that spans a relatively small area. Most LANs are confined to a single building or a group of buildings. MAN. A metropolitan area network is a computer network larger than the local area network. It usually spans several buildings in the same city or town. And lastly, WAN or WAN. It is a wide area network in comparison to a MAN and is not restricted to a geographical location, although it might be confined within the bounds of a state or a country. The largest WAN in existence is the Internet. In other words, local area networking is used as a tool to share resources. It means that all the devices attached to the LAN share a single communication cable like coaxial cable, UTP cable, or fiber optic cable that serves as the communication medium for all the computers.
The physical connection to the network is done by installing a network interface card (NIC) inside the computer and connecting it to the network cable. Once the physical connection is made, it is up to the network software to manage communication between the workstations in the network.
Finally, we have the network hardware. All the physical devices, peripherals, and equipment which are required to build a network are called network hardware. For example, workstation, modem, router, network switch, access point, etc. Networking hardware consists of computers, peripherals, interface cards, and other equipment needed to perform data processing and communications within the network. These hardware devices are universal in nature, standardized to be used globally, and interconnected with each other with the help of a transmission-reception medium. The main devices of networking are categorized as basic devices and advanced devices. Basic devices. The commonly used hardware in LAN are network interface cards or NIC, cables and connectors, hub and switches. Advanced devices.
The commonly used hardware to develop large size network along with the basic hardware devices are server, router, bridge, firewall, wireless access point. Students, before we start to understand networking hardware, we must understand terms like workstation, terminal, node, client and server.
Workstation. A computer with network interface card and media used for communication is known as workstation. This is also sometimes called by various other names such as client, terminal and node. Thus, we can say that any workstation is a computer that is configured with a network interface card, networking software and the appropriate cables. Workstations do not necessarily need large storage hard drives because files can be saved on the file server. Almost any computer can serve as a network workstation. The following are the types of workstations: smart terminal, a computer system with processor and memory for the purpose of processing of data is called a smart terminal. Then we have a dead or dumb terminal. A computer system with no processor and no memory for the purpose of processing of data is called a dead or a dumb terminal. It is used to access services provided by a server at the user end and performs processing at server end. Then we have something called a server, a computer system which provides various services to the workstation is called server. The network server simultaneously responds to all requests from several network users. For example, one can load a word processor program to one workstation, receive a database file from another workstation, and store an email message at the same time. This type of processing requires a computer that can quickly store and share large amount of information. Let's see the guidelines for configuring such type of server. High-speed processor, big size of RAM, multiple large and fast hard drives, additional expansion slots, high-speed network interface card.
Servers are very fast computers with a big size of RAM and storage space along with one or more high-speed network interface cards.
The network operating system facilitates tools to share server resources and information with network workstation. An administrative permissions handling system is required to access information to the need of the users. It is in common practice for small size networks that a single network server may provide access control, file sharing, printer sharing, email, database, and other services.
In this part, we will discuss in more detail about different hardware components of local area network. We will examine each component's role in the network and how the components are physically connected to form the network. The network employs two types of signaling method. One is baseband transmission, second is broadband transmission.
Baseband transmissions. These transmissions use digital signaling over a single wire. Communication on baseband transmissions is bidirectional, allowing signals to be sent and received but not at the same time. To send multiple signals on a single cable, baseband uses something called time division multiplexing, that is TDM. TDM divides a single channel into time slots. Broadband transmissions. In terms of LAN network standards, broadband transmissions use analog transmissions. For broadband transmissions to be sent and received, the medium must be split into two channels. Multiple channels are created using frequency division multiplexing, that is FDM. To employ any of the method, we need to deal with network hardware devices. Now, let us talk about the functions of basic devices.
Now, we will describe the role of a network interface card in network communication. NICs, also called network cards, is a mechanism by which computers connect to a network. A message is placed in the packet header with the address of the destination station. Then NIC transmits the packet onto the LAN. This packet is transmitted as a stream of data bits. As network is developed with shared cable, all the stations attached to it see the packet traveling on it. It reaches to all NIC at each station. Then NIC checks the destination address in the packet header to determine whether the packet is addressed to it or not. If the packet is addressed for a particular station, then the NIC at that station copies the packet and takes the data out of the envelope and give it to the computer.
Types of network interfaces. Network interfaces come as add-in expansion cards, PCMCIA cards used in laptop, embedded into the motherboard, and Wi-Fi network cards. Mostly it is seen that when an NIC is plugged in the computer, a network interface typically has at least two LEDs that indicate certain conditions. These conditions are link light. This LED indicates whether a network connection exists between the card and the network. If the light is not blinking, it indicates that something is wrong with the network cable or connection. Activity light. This LED indicates network activity. Under normal conditions, the light should flicker periodically. Busy network is shown by constant flickering. In network, each workstation has to be assigned with its identification number or address. Cables. When it comes to working with an existing network or implementing a new one, we need to be able to identify the characteristics of network media and their associated cabling. Whatever type of network is used, one or the other network medium is needed to carry signals between computers. Two types of media are used in networks: cable-based media such as twisted pair or wireless networking such as radio waves. Cable is the medium through which information usually moves from one network device to another network device. This is the medium used to connect two or more computers together. The transmission media determines the quality of the network system. The most common forms of electronic transmission are solid and composite wire cables.
The several factors for selection of cabling for a network are cost, expansion capabilities, bandwidth, signal attenuation, and EMI, electromagnetic interference. Different types of cables have different specifications that affect these factors, and each organization has different needs.
Bandwidth is the difference between the highest and lowest frequencies of the transmission. Measured in hertz, bandwidth is a factor used to evaluate cable. In networks using cable-based media, there are three basic choices: coaxial cable, for example thick, thin coaxial cable; unshielded twisted pair cable, that is UTP, Cat5 or Cat6; and fiber optic cable, single mode or multi-mode. Connectors. There are different types of connectors. Depending on type of devices, we select appropriate connectors. The commonly used connectors are BNC, RJ11, RJ45. BNC is the British naval connector. It is used with coaxial cable. RJ11, a registered Jack 11, is a telephone connector used on modern telephone lines. And lastly, RJ45. A registered Jack 45 is an 8-wire connector used to connect computers to category 5 unshielded twisted pair cables in a network. These are the devices which are the central part of network through which other workstations are connected. These may be hubs or switches. Hubs. Hubs are simple low-cost network devices. With the use of cables, they provide everything needed to create a small network. Hubs with 4, 8, 16 ports are available for networks. An unintelligent network device that sends one signal to all the stations connected to it. All computers or devices are competing for attention because it takes the data that comes into a port and sends it out to all the other ports in the hub. Hub resides on layer 1 of the OSI model. Computers are connected to a hub through the twisted pair cabling.
Generally, hubs are referred to as either passive or active. Now, passive hubs. Passive hubs do not need power and they do not regenerate the data signal. They are simply point of contacts for wires. Active hub. Active hub regenerates a signal before forwarding it to all the ports on the device and requires a power supply. Due to the inefficiencies of the hub and the constantly increasing demand for more bandwidth, hubs are slowly but surely being replaced with switches.
Switches. Switch looks much like a hub. Despite their similar appearance, switches are more efficient than hubs and more desirable for today's network environments. As in a hub, computers connect to a switch through twisted pair cable. Multiple switches are interconnected to create larger networks. Switches offer significant operational advantages over hubs. Rather than forwarding data to all the connected ports, a switch forwards data only to the port on which the destination system is connected. It looks at the media access control, that is MAC, addresses of the devices connected to it to determine the correct port. A MAC address is a unique number that is stamped into every NIC. By forwarding data only to the system to which the data is addressed, the switch decreases the amount of traffic on each network link dramatically.
Finally, functions of a switch are splitting large networks into small segments, decreasing the number of users sharing the same network resources and bandwidth. Understanding when two devices want to talk to each other and giving them a switched connection, then helping prevent data collision and reducing network congestion, increasing network performance. And last, residing on layer 2 of the OSI model.
Many devices are used to create networks, and we have discussed basic network hardware devices in this lesson. The devices discussed in this lesson are vital for the network as well as for the real world. NIC, hubs and switches provide a mechanism to connect devices to a network created with twisted pair cabling. Switches offer speed advantage over hubs because they can use full duplex communications. They also create dedicated paths between devices, reducing the number of collisions that occur. Both hubs and switches are available in managed and unmanaged varieties.
The network operating system plays an important role to handle the communication within the network. Finally, we have learned to develop network of computer with NIC in a computer, and these computers are connected with cable via hub and or switch. In the next lesson, we will discuss about the advanced